As you've learned, variables are classified differently depending on the characteristics of that variable. We often refer to a variable's classification as its scale of measurement. You need to know the scale of measurement for each variable in order to determine the statistical procedures appropriate for use with that variable. You already know two scales of measurement for categorical variables, nominal and ordinal. The nominal scale enables you to categorize or label variables, such as gender or beverage type, where there is no ordering to the levels of those variables. The ordinal scale indicates categories that can be ordered in a meaningful way, as in size of beverage or severity of disease. There are two scales of measurement for continuous variables, interval and ratio. Data from an interval scale can be rank-ordered like ordinal data, but also has a sensible spacing of observations such that differences between measurements are meaningful. For example, in measuring patient temperature, you can indicate specific differences in temperature between the standard measurement of normal body temperature, 98.6 degrees Fahrenheit, and an observed body temperature of 98.2. Interval scales lack, however, the ability to calculate ratios between numbers on the scale. In the case of the Fahrenheit scale, for example, there is no true 0 point. 0 does not imply the lack of temperature. Another example of an interval scale is pH value. Seawater, which has a pH of 8, is not twice as alkaline as tomato juice, which has a pH of 4. Data on a ratio scale is not only rank-ordered with meaningful spacing, but it also includes a true 0 point, and can therefore accurately indicate the ratio of difference between two spaces on the measurement scale. For example, the Kelvin temperature scale has a true 0 point. A temperature of 50 Kelvin is half as hot as 100 Kelvin. Another example of a ratio scale is money. If an individual has $0, this does imply an absence of money, and one individual can have twice as much money as another.